Hello, everyone, and welcome to another episode of Nelson's Corner with your host, Mr. Nelson LINQ. Nelson.
Hey.
Hey. And also joining us tonight, we've got Mr. Zach.
Hey, what's up?
Yeah, not much. Myself, Jason Busby. Now, tonight, we're going to just let Nelson kind of have free roam of things once again before we jump back into a regular routine of design patterns. Nelson had a few more things that he just wanted to show that could end up benefiting us as we walk through further design patterns. So, Nelson, what you got in mind?
I was just going to go over yield, the construct, as well as seeing if we can re-implement a few of the LINQ methods.
Very cool.
Cool.
Show how those work. This was actually inspired by a series of blog posts that John Skeet has been doing over on his blog, and I posted those in the forum.
Over on 3D Buzz?
Yeah.
Yeah, awesome.
Very good series to go over. But yeah, I just wanted to go over some of the kind of the requisite knowledge to kind of follow that series basically, and to show some of the simpler LINQ operators being implemented.
Okay.
Killer.
Okay, so you remember extension methods, right?
I do.
Zach?
Yes. Yes, I do.
So if we have an interface like that, and what is it like?
Your horrible naming is what it does not like.
So if we go ahead and grab a class that implements this, and then we go ahead and make it having some problems auto-generating code for me. Okay, so we now have an object that implements an interface, and I know you just said that you did remember extension methods. I just want to go over the syntax one more time.
Sure.
Really quickly. To do extension methods, you have to be in a static class, and then you have to create public static methods with this, then the type you're extending, which can be an interface class or structure, and then arbitrary name.
Oh, don't get into the whole this and that
Oh,
stuff.
come on, it's great.
It is, but it's tremendously confusing.
Though it is what I use in my own code. So
fine.
Okay, so now we have obj, and we can now do dot, and we now have method A. And the reason we have method A is because that the interface that we're extending with this extension method applies to an interface that was implemented by this class.
Okay. Yeah.
Yeah. Okay, so IEnumerables. I think we talked about them for a few minutes in the first video or something. But we talked about how we have how for each loops work. So if I were going to go ahead and do create a new list of stuff, we can do a loop over it, print it out, and then I'm just going to go ahead and compile, and then I'm going to head over to Reflector and show what the actual code is that the C# compiler generated.
Now, how did you just do that real quick? You hit something. I heard a hotkey.
F5.
Okay, just making sure.
The standard refresh key.
And I'm going to try to stand on you about those to make sure you at least say what hotkey you're hitting out loud.
Okay, so we go into main, our method, and yeah, it's going to do this to us. Oh, come on. See, it's figuring out, it's not going to show us exactly what's going on.
Now, is this something that just gets lost in translation with this kind of being interpreted into, I don't know, machine language and back again?
Yeah, what's going on is the C# compiler is actually generating some code for us in IL, and then Reflector is picking up on that fact and showing us what it looks like in C#, even though this isn't actually what's being done. Unfortunately, no, Manage C++ also implements that, but Delphi.
So, I mean, is it something like when you go from English to Chinese and then back to English, you don't really get the same thing?
Well, we're getting the same thing, and that's the problem. we're not getting what the compiler actually printed out. We're getting what the compiler printed out and then reinterpreted by reflector. So it's detecting that there was a for each loop here, even though in the actual IL code that was generated, there is no for each loop, because that's not an IL concept. So I'm going to go ahead and just write it out longhand, what this would be, what this actually logically translates into.
Okay.
And then we can go ahead and put just to demonstrate that this code is indeed equivalent, we can go ahead and
Right life. Be an interesting concept.
Go ahead and we see that it's the exact same output.
Yeah.
So this is what all for each loops are turned into by the C# compiler.
For the most part.
How do you mean?
Well, there's a little bit more. It's with for each, it's wrapped in a try-catch finally, and there's a little bit more to it. But for general purposes, yes, we can say this is what it's turned into.
Okay, so this enumerator, get enumerator method, is provided by the IEnumerable interface that arrays and lists and linked lists and dictionaries implement. So this iterator is an object that is, well, it's a numerator, I guess you could say, but you can think about it just like if you are a C++ programmer, you can just think about it like the STL iterators, where we are getting a pointer to the first element in this collection, and then we're repeatedly moving over it and getting the current item. And now the reason that's important is because when we re-implement LINQ, we have to kind of understand, well, what's the iterator actually doing? So, okay, so there's a construct called yield in C#, and yield is a way to basically inject your own code into the invocation of move next. So if we go ahead and create a method that returns an IEnumerable, and that's not imported, so it's going to go ahead and add a system collections generic of type int. Actually, I'm going to do something. No, I'm just going to do this. So we can return null. That just returns that, or we can return a array, anything that implements IEnumerable event. But we can also do this. So if we were to iterate over this, I'm going to go ahead and write out the this in longhand. Okay, and the reason we get that is the yield return construct actually turns this entire method into a state machine, essentially. What's really interesting about the yield return construct is that behind the scenes, it's actually, the C# compiler is creating a class for us that implements IEnumerable of t, and is implementing this move next. And then every time this move next is called on this enumerable, it basically moves one step forward, and then one step forward, and then returns that, or rather it sets the enumerator's current value to whatever value we're yielding. There's actually a lot of interesting properties about methods that use the yield return construct. Like, for example, if I were to run this, you see how that showed up on the screen?
Mm-hmm.
This exception didn't get thrown until the first time move next was invoked. So we actually invoked the method right here, or right here rather, and it invoked it. I mean, according to how you would expect C# to work, this would throw an exception right here, and actually if we remove all the yield statements, we get that exception right where we expect it to. Actually, if you look at the call stack, that exception happened as a result of the method invocation of doStuff. So when we add in those yield statements, we get, in essence, the deferred execution behavior that you've been seeing with LINQ, where this method is never actually invoked until it needs to do a move next. And it's really interesting how the compiler handles it. So if we go ahead and do a build and go back into Reflector, remember that the yield return is a C# construct. It's not an IL construct. So the C# compiler is actually generating code for us. If we look at our doStuff method, it's going to look kind of weird. It's returning a new doStuff. We never created a class called doStuff. The C# compiler did for us. And so if we go into our doStuff class, we see that the C# compiler created this entire class. It had to implement the IEnumerable and IEnumerator of type int. And if you go into the moveNext method, so remember that's the moveNext method that's being hit right there, or if this were a for each loop, that would be what would be called every iteration. If we go into this, we'll start to see our code. So you see that private bool moveNext throw a new exception, which is what right there. If I were to move this, it'll actually print out some more code. And this is actually incredible. I think it's really interesting, but you guys can disagree. You see that the first time moveNext is invoked, it performs. Actually, I'm going to go ahead and make this more clear. Okay, so you see that the C# compiler is actually optimizing that out. But you see that the first time moveNext is called, the state is going to be 0, and then it's going to set current to 20. And then in the next case, it's going to set current to 40. The second time moveNext is called, and so on. And all of the code that we put in here is actually going to be sandwiched in between those lines. So it basically cuts this entire method apart into little pieces and stuffs it in a state machine. So if we were to rebuild and refresh, we'll see that the code we just wrote got sandwiched right there. So in the first iteration of first time moveNext is invoked, we get state of 0. We set current to 20, which is yield return 20. So that current value gets set to 20. Then in the next case, we have a case of 1. So then the console.writeLine is invoked, and then we set the state to, or the current to 40, which is right there. And then the third time and the fourth time. It also does some really weird stuff, like if we were to do a loop in here, any sort of loop. I'm just going to pick on for loop right now. Well, this gets a little weird. You'll see the behavior of this is going to be just like what you expect it to be. It's going to be 50 through 59 because we're looping over from 10 times, and then we're returning I plus 50. And if we look at the generated IL, it's going to be pretty funky. It creates a state of 0, so there's only one state, and then it uses these go-to statements. It's really bizarre if you look at it, but it basically stuck a go-to statement in the middle of our loop so that we can iterate it every single time. And the more complicated method that you get here, the more work that the C# compiler has to do in order to chop it up into this moveNext method. But so far, does that make sense, Zach?
It's getting there. I mean, it took me a second to actually see what yield was doing, and I'll be honest, I'm not familiar with just slinging around the term state machine that much. I mean, I've heard it, but I've never really sat down and tried to work out exactly what was and what was not a state machine. What I'm getting out of this, to try to answer your question without just saying yes or no, is that what yield is doing is acting as kind of like a roadblock in the code, where once we hit that, all of that code up to that point is being thrown into a switch statement. And I'm fine with using switch and case, but that's really what I'm getting out of this more than anything else.
Okay. Let me go ahead and maybe this might make it clear, then I'll move on. Hopefully. What do you think so far, Jason?
Yeah, well, I think it's great for somebody that has an understanding. I think keep pushing at it for Zach, since he's new to it, especially when you get over into how this can be applied for, the concept of deferred execution.
I mean, it doesn't look that bizarre. I mean, it doesn't look like the kind of thing that's got me freaking out. Like, oh, I have no idea what you did. I see what you did, and I see generally what the IL is doing with your output, which gives me a pretty good clue as to why you'd want to use this, but I'm not quite there yet. Though, hey, does that IL mean that it's okay to use goto statements?
No. Well, this isn't actually IL. This is C#. But if I were to go into IL,
even better. I mean, that's the computer.
There's what actual IL looks like.
All right.
Yeah. There are goto statements. I can't remember which operator is goto.
But that doesn't mean it's okay for us to use goto in our C# code then.
Never.
Okay.
Or
Actually,
he'll come down here and stab you, and I'll pay for his ticket.
Did I already mention that the only reason I know gotos exists is after reading the language spec? Like, I seriously have never seen that used in production.
I mean, the computer said we could do it. Heck, the computer actually did it.
Yeah, well, I'm trying to figure out how to implement move next to replicate this, but I'm actually probably not going to try. It would look all funky. Because this really is weird. Like, it's chopping this method into what would go here in a really bizarre way, and it's kind of hard to express. We could just do this. We could give our do stuff guy a private int counter, and then every move next return counter plus what was it, plus 50? Yeah, plus 50. What doesn't like that for? Oh, it's never mind. It's current equals that. My hands are freezing.
I know how you feel.
Okay, so this would be in implementation. You can just ignore all these operators or all these methods.
Mm-hmm.
This would be what it would look like if I had written this out, this iterator out.
Right.
And that's what the C# compiler generated for me.
Mm-hmm.
Now, why you would ever use this?
By this, of course, you mean yield. Why you'd ever use yield?
Yeah, I've only ever came across an instance once where I've used it in actual real production-y code.
Yeah.
Jason mentioned to me a while ago that he had used it in one of the XNA videos.
We actually used it not in XNA but in Unity, in yielding the execution of a method partially through.
Yeah.
For a certain amount of time before we let the method finish off its execution.
Like kind of a directed pause? Like,
kind of, yeah. It was just yielded execution, basically. Go ahead, Nelson.
I actually did this a few days ago. I had something like this. Well, I don't know. I'll just write arbitrary stuff. I had like get available discount types, and then I had the discount object being passed in. I'm just going to pass in an integer. And then I did stuff like, if discount some condition, yield return something. And then if discount is smaller than some condition, then yield return something else. It basically cleaned up the code to a point where instead of just creating an array where I'd have to write an if statement. If this condition, then add this item to an array. I just wrote it out like this in this method because right now there's only one integer being passed in, but I had a lot of different conditions in here that would have been really complicated to put them anywhere else, but having yield made the code a lot cleaner. Does that make sense, Zach? Or
I'm with you. Yeah. I mean, as a debugging mechanism, kind of. Am I missing that?
no, not so much as debugging as much as making your code cleaner.
Okay.
Because I had this list of discount types, and actually there were modifier types, and only certain discounts could have certain modifier types.
Okay.
And so the UI needed to know which kinds of modifier types I was allowed to put in, but I didn't want to write if this condition, then push this new modifier type. If that condition, then push this modifier type. Instead, I moved it out into a method with yield. And admittedly, if I had done it the other way, the savings and readability would have been not very great, to be honest with you. But it did look a lot better. It did flow a lot nicer. As far as like really practical, there's no other way to do it other than to use yield cases. There actually aren't any, simply because all yield does is a C# compiler feature that writes code for you. Ultimately, if you ever needed anything that yield provides, you could ultimately implement your own IEnumerable and your own IEnumerator. Does that make sense?
Yes, it does.
Okay, so now we can do stuff like this. Let's go ahead and do a where. And
There should be a lowercase where?
no.
Oh, okay. Oh, okay. You don't mean... sorry.
Hold on. Need a source. I'm kind of running off the screen here, so let me actually hide these guys. Okay, so let's go ahead and do and then of course it's telling us that we can make that into like a statement. This is actually really similar to how the where method is implemented in LINQ. So we can use it like, for example, we could say bar enumerator equals where items, and then pass in a predicate. I is less than 5, get enumerator. So if we go ahead and print this, we'll get what we expect, 1, 2, 3, 4, and no 5. This is how LINQ allows us to defer execution, essentially. For example, if I were to go ahead and do right up here, you'll see that this method is actually being hold on, that was a bad example. It should be inside the for each loop. You'll see that this write line is being executed every single time.
Mm-hmm.
So this is essentially how. And do you understand? Like, is there any specific thing about this code that doesn't make sense that I could expand on?
Not so far.
Okay. I'm just asking if you kind of understand this, yeah.
I'm not sure what your question is. I'd love to answer it, but I'm not sure what it was.
Yeah.
You can do it, Nelson. You can do it.
Well, would you be able to write this out yourself? But I know if you haven't really worked with generics very much, but
yeah, that's the. I mean, generics still throw me off a little bit. But I understand where you're coming from with them. I understand very generically how they work. Like I said, I've followed everything you've pointed out thus far. Do I see a spot in any of the programs that I have written or considered writing where I see myself really wanting to reach for this? Not right now, but that doesn't mean anything.
Well, no. But it does give you a better appreciation. Do you agree that it gives you a better appreciation of how LINQ works, for
Yes.
example?
Okay.
Because, I mean, we can go ahead and replace this with a for each loop. We can just say... And now it looks exactly like broken code.
Because that's what it is.
So now it looks like exactly like what you'd be used to, but it's equivalent code.
I mean, you're trying to make a reference to the actual where statement when using LINQ.
Well, no, this isn't the LINQ where. This is my where.
I know that, but I mean, are you using your where to illustrate what the LINQ where is doing?
Yes.
Yeah, I mean, I understand that.
Okay.
And then using yield, he's showing where this deferred execution is coming from.
Yes.
Right. Because deferred execution is really awesome. Let's say you... okay.
I was going to ask you this. Can the yield statement be used as a shorthand way to create things like switch case statements?
In a really roundabout way, yes.
I mean, I'm not saying it's a good idea, a bad idea. I'm just asking generally.
It's more about not switch statements themselves, but a method that does something different every time it's called.
Yeah.
So what you were seeing was the first time the method was called, it would do some of
this
the
stuff.
code.
The next time it would do this stuff.
And then it would pick up and continue with this next
Okay,
bar.
all right.
Right. And if we go
Believe
ahead
it or
and
not, that actually helps.
if we look at the reflector,
Yeah. The reflector.
there's only one. Isn't that from a 80s movie, Highlander? There can be only one.
It is.
Very good.
So now you see some really crazy stuff in here.
Yeah.
But essentially, what this is doing is every time it's called, it's doing something different.
Yeah.
But yeah, so... Alright, let's go ahead and re-implement where. I mean, we can just do this. We can just create a static class up here. Call it rLINQ. And then it's not valid. So now I'm actually just going to basically yank all this stuff and turn it into an extension method.
Mm-hmm.
So I'm going to say this. ReSharper failed me.
Or did you fail ReSharper?
So you see that I don't have using system.link anywhere. I'm actually going to say, instead of where, I'm going to call it rwhere, so we don't confuse it with LINQ's actual where.
Probably good.
So now we can just do stuff like this. We can do for each var item in items.rwhere, and we don't get it because it's not public. Now we get rwhere, which behaves exactly like
The real where.
LINQ's where.
Yeah. With the additional benefit of writing bleh everywhere.
Yes. There's actually a kind of a really important thing, and Jonsky, he actually talks about this in his introduction. But if you look at this really closely, do you immediately see anything possibly wrong about this code, Zach?
Not immediately, no. I mean,
You, Jason? Or... Well, think about how yield affects your code, and how, yeah.
Not right off. That's hit every single time.
Well, it's not hit the first time you call it. Meaning if I were to do this, actually, hold on. That's actually a valid use. If I were to do this, what would the expected output be, do you think, Zach?
At this point, I would think it would throw an exception, your argument exception.
And that's an interesting thing about yield, because this method isn't called until the first time we iterate over this.
Mm-hmm.
So if we were to iterate over this by doing, I'm just going to simulate it by doing a filtered items.getEnumerator.moveNext. Now we get our exception.
Yeah, go ahead and jump back over into Reflector real quick. And refresh.
You want me to locate the method?
Actually, you can, but I see why.
Right. Let me bump this into .NET 1 land where there was no yield. All it's doing is instantiating the magically created class and returning it. This code is never actually executed until our magical class gets its moveNext gets called, which is done right there.
Exactly. Yeah.
So that's that's something that he went over in the first thing.
Yeah, which is be careful. Don't let that bite you in the butt.
Yeah. So his sort of solution was to or probably the solution of how LINQ is actually implemented, or LINQ to objects, I should say, is to replicate this entire method minus its publicness or its extensionness. Put the actual code in here, rename it something like rware implementation, and then just return that. So now if we were to run this code, or hold on, let me remove that moveNext call. Now if we were to run this code, we get the exception the second we call rware.
Very nice.
Because we've abstracted away the implementation, so there's no more deferred execution, at least as far as the validation of the arguments go.
Mm-hmm. Yeah, that's very cool. Yeah, it makes
perfect sense.
Okay, so there's where select is pretty much just like this, except for it says select instead of where.
What's the difference between the two?
Well, here there's actually two generic arguments. There's tSource and tResult, because our predicate, which is no longer a predicate, I'm going to call him the projector. Instead of just returning bool, he returns an arbitrary value. And basically, I should have probably written this out in hindsight just to kind of show what's going on. We're basically, instead of yield returning value if the predicate is true, we're going to yield return the projector projected on the item. And we got to add the tResult in there as well. And then we get an error because we're not returning tResult, we're returning tSource. And then I'll go back to that in a second, but if I were to go ahead and say instead of rwhere, we do rselect, and we do O times 5, we'll now get 5 times every single one of those items, because we're now projecting this lambda on every single one of these items. And so basically the implementation reads, it's very similar to where, except for our function that we're passing in returns a result.
Instead of just a true or false.
Right. And then that's what all of our items are mutated by this projection.
Yeah.
There's actually another overload. I'm going to stop with this argument validation stuff, just because it's going to take up all of the screen. If that's okay.
Yeah.
So we'll just pretend that it's there. Where there is argument validation on every single link to objects method. You can read more about that in the MSDN. Okay, so now they're extension methods again. So there's actually another select. Actually, is it the where or the select that has that? I've never used this particular one. Do you remember if it's the select that has the index or the where that has the index, Jason?
Don't know.
It was the select, but I don't want to get this wrong.
Never used that.
Yeah, I've only found it in looking through the stuff. Yes, it's select that has it. So select actually has another overload that is completely identical, except for the projection has a, is it the first or the second? It is the second argument. It is an integer. And then all it does here is this for each loop actually becomes a for loop.
Mm-hmm.
So it's going to be that dot get enumerator, iterator dot move next, or hold on, iterator dot move next. Yeah, I don't know how. I'm just going to put this into a while. Oh, there we go. Iterator dot current, and then actually no, hold on. I'm going to do this outside because we're going to be doing because the second argument is actually the index of the item we're currently iterating over. So we can just cheat and use a for each loop and then have an index being incremented outside. Actually, we don't need that. We can just do this. And then if we were to test this out, we could change our projection to accept two arguments, O and I. I'm actually going to call this C and I, current and index.
Mm-hmm.
And then I'm going to break this out into a string.format. So index current. And then we're going to change this up a bit so it doesn't actually coincide with their indices. And if you were really re-implementing LINQ to objects, you definitely want to actually write out good tests for all these things, but we're just kind of going over them really quickly. So you see that our overload does work. And then if we pass in a lambda with two arguments,
Mm-hmm.
the first argument is always going to be the current item, and the second argument is going to be the index. And that's because we're actually invoking the second overload of select.
That's very cool.
Yeah, it's a very neat trick.
Yeah, we might as well go in the same order as John, at least a few more times, because there are a few cool ones. If you guys are still up.
Yeah,
Oh,
man.
please, yeah, continue. It's good stuff. It's cool to actually see how this LINQ stuff works. Now, granted, at the same time, I don't really ever see myself typing this stuff out. Not if LINQ is actually doing its job.
Well, yeah, true. But it's always important to know how it works behind
Absolutely,
the scenes.
and I really appreciate that.
And I do want to reiterate over one more thing here. We're going to chain these two together, our where, then our select. We're going to put in a multi-line lambda here, and it's going to start to look a bit ugly. I don't know. Let's do increasing numbers so we can have some sense. And then O is smaller than 7. And then we're going to do system.threading.thread.weight. No. Current. Is it current thread? Weight. No, it's sleep. There we go. Okay, that was actually a really bad example. We're gonna need, we need to break this guy out into multiple multiple line expression, and yank this guy out, return, and then add our thread. I'm adding a system.threading reference to the top. 100. Okay, Zach.
Yes, sir.
How many milliseconds is this program going to spend inside thread.sleep?
I mean, you've got 500, but the nature of your question suggests it's a trick question.
Well, you have to read this really. This Jason probably hates me.
500 times 7. So I mean, what, 3,500?
Well, where'd you get 7 from?
The fact that we were running a loop just above that.
Yeah, this.
No, it's okay. Just look at what that lambda is saying. It's not saying go 7 times. It's just where O goes to O being less than 7. So
okay.
in his thing above, what all is less than 7? We got 2. We got 5.
So okay, so I see what you're saying. Sorry. So that's 1,000 then.
Yes. And so if we wait, it should only wait 1 second. Yep. Total of 1 second.
Yeah.
And that's one really, really important thing to know about LINQ, is that when we do rSelect then .rWhere, rWhere is only returning elements that match this predicate, so therefore rSelect is only being iterated over those elements. If we were to reverse this, how long do you think it's going to wait for now?
Well, now isn't it just going to iterate over everything now?
Yes.
So I mean, it's however many arguments you've got in there. 2, 5, 7, 9, and 15. There's 5. So 5 times 5 is 2,500.
Yes, and even though our for each loop is only printing out elements that are smaller than 7 due to this where,
right?
Because this where occurred after this select,
right?
The select is getting every single element.
Mm-hmm.
So I just wanted to show that real
Gotcha.
fast. Okay, so we have range, and range is actually funny because it's not a extension method. It's a system.link.enumerable, isn't it? Yeah, there we go. .range, and this is a part of LINQ, but it's not a extension method, or it's a part of LINQ2 objects, but it's not an extension method. And all it does is it generates a sequence of integral numbers within a specified range with start and count. And if we were to implement this, our implementation would look something like, let's go ahead and add a public static, and this isn't going to be a extension method.
Okay.
It's just going to be a normal method. What was it? Start and count? I already forgot.
I mean, you're making your own.
Yeah, start and count.
Okay. I have a very poor memory, which is why I like ReSharper and Visual Studio so much.
Understood.
Actually, using yield, how do you think you would implement this, Zach?
Oh, let's see. Yeah, I'm sorry, I don't know.
Right. Well, we would basically write code that would iterate this many times. So start and count. So it would be I equals start, I smaller than start plus count. So this would be the beginning, is we're creating a loop that... Oh, what was going on there?
You see how the loop's working, Zach? Where if you send
I
in
do.
start of 10 and
Yeah.
you're going to count
And
5
then
up.
When inside this loop, we simply yield return
And the value I, yeah.
I do want to point out right now that the actual implementation of our range does argument checking as well as making sure that start plus count isn't greater than int.max value. But, I mean, yeah.
Basically just verifying that all the values are good.
Yep. So I'm going to go ahead and delete items, and I'm going to do rLINQ.range, or rRange, 500, and then I'm going to leave the where, and then print this out. So you see we get 5, 6, because we start on 5, we're going 100 times, and we're only selecting items that are less than 7.
Mm-hmm.
So yeah, so that's pretty straightforward method, but again, it uses deferred execution. with the yield return. And it's really handy. I actually use range a lot. There's also empty. Empty is actually a funny one because... oh no, never mind. Ignore me. Empty's not a funny one. It's actually very straightforward.
It's actually a very serious one.
Empty simply is a method that has a generic argument, and really all it does is... Actually, I have no idea how they implement this, if they return an array or a... I don't know. I'm just going to do this. I can't remember which data structure they actually use in LINQ to objects, but essentially this is the behavior of empty, is it returns an empty enumerable.
Mm.
Actually, this isn't the behavior of empty. I just realized why I thought it was so confusing. According to, I don't know if this is what LINQ to objects does or what's documented, but the object returned by empty should be the same object between all types. So if I do rempty int and then I do rempty float, those two objects aren't going to be the same. But if I do rempty int and then rempty float or int again, then let me write this out.
It's all good, man. It's all good. No worries.
The top one should be true and the bottom one should be false. But you see they're both false.
Yeah.
Because it should return the same object every time. And there's actually a really funny behavior of C# that we can actually abuse to make this work. And I unfortunately can't claim credit to this. I read this in the John Skeet articles. But I will say that if you make a normal class, just make a normal class, give it a public static oh, it has to be a generic class, sorry. Public static array of that source, and then you do equals new, and then of type tSource 0, and there we go. And so now if we do this, I don't, this isn't something I'm going to quiz you on, Zach. But
It's okay if you do. If I don't know, I'll just tell you I don't know.
now we get our expected behavior, true and false. So rempty int equals rempty int. This is returning the exact same object. This is returning different objects because one's a float, one's an int. And that's an interesting behavior about how static methods or static fields work in static or generic classes, where the first time we reference this generic class with a specified type argument, all of his members get initialized. But then when we access this class with a different generic type argument, his members get initialized again for that type argument. And that's why we get the same class every single time we access rempty implementation of type int or rempty implementation of type float.
Mm-hmm.
So does that make sense, Jason?
Yeah, it's actually very cool.
Okay, so there's empty. Then there's repeat, which is, I mean, pretty obviously straightforward. Repeat is an extension method. So, no, it's not. Repeat is not. It should be an extension method. I would like it to be, but it's not. Repeat is really, really obvious of what it does. Almost so obvious that I don't really have to talk about it very much. Okay, Zach.
Sir.
Without looking at the name of this method, what do you think it does?
Well, you should have named it something else, because I got to read the whole code. You know what I'm saying? Let's see. While I is less than count, we're going to keep iterating, and then return whatever our source was. I just got to see this stuff in use, man.
So
I have a tricky time without just looking at a
let Nelson throw it up there.
a random block and just saying, here's what they should do, without actually seeing it being done.
I forgot the R prefix.
And see, you're forgetting stuff. That doesn't help me. I'm just kidding, dude. I see. So it's taking whatever value you punch into that initial string, and it's it's looping over that the number of times that you specify in the second argument.
Yep.
Yeah, if you scroll back up, yeah, you can see that. So our T source that we're sending in this case was a string, source being high and int being 500. And then when we get down here, we just simply loop from 0 to the number of times that you want it to repeat it, yielding a return of the source each time, which in this case was high of type string.
I really do have to also show this one last one at least, because I don't really know how we're doing for time, but this one is incredibly important. There's actually a huge problem with this method. Well, besides that, it's I'm not typing it right. Okay, given we have an IEnumerable, and remember, IEnumerable only gives us a get enumerator. That's the only method that we get from IEnumerable, because this could be an array, it could be a linked list, it could be anything. It could be the result of a yield statement. So we don't have any access to a count member anywhere. So how do we calculate? And this is a LINQ method. There is a method called .count.
Yeah.
How do we calculate the count of an IEnumerable?
Well, I mean, I keep thinking there's got to be some sort of internal mechanism that numbers what's in there, and we're taking the highest factor of that.
Well, unfortunately, there's no way to, because just as you saw with yield, this turns it into a state machine, and there's no count member. There's no internal count member to that. So this getting the count of an IEnumerable it's impossible to do in any way that isn't actually iterating through every single item in the list until you hit the end.
Okay, so I mean, you're saying that it's actually got to go in there and check and see how long it is one by one.
Yes.
Okay.
I do want to say right now that the link to objects actually cheats. It does something like this. But if you're not on an, actually I think it's iCollection that they do it for. One of these guys. So if your IEnumerable happened to be an iCollection, it'll just cheat and use the internal representation. But if it's not an iCollection, it actually goes behind the scenes and loops through every single item. So we just do get enumerator, next,
Or something close to that. I mean, do you just have to check and see when it finally reports back null?
Move next handles that.
Okay.
So that's how it has to be.
Yeah.
And the unfortunate part about this is, remember, in move next, we're talking about code like this. We're talking about yield return. We're talking about things that could potentially be very expensive.
Yeah.
So that's why you have to be very careful with this operator. And if we go ahead and do console.writeLine items.rcount. Should get 500, unless there's an off by 1. Ah, there we go, 500. So yeah, that's how count. Be very, very careful of count, because unless you're working with, it's either iCollection or iList, unless iCollection actually implements iList. Or, I guess not. Maybe iList implements iCollection. I don't know why there has to be a difference. Whatever. It's either iList or iCollection that has the optimization in there for. Yeah. Should I keep on going? Jason?
It's up to you. If you have some more stuff you want to show it.
Well, I think this is actually a really good way to get familiar with LINQ.
Absolutely.
Like, do you feel that you have a better understanding of like what LINQ actually gives you, Zach?
I do. I have a better idea. Well, see, understand that in the limited amount of code that I've written, I haven't used that many of the LINQ operators yet. But the ones that, I mean, like, okay, so I've used count, I've used select, and it's been really interesting seeing what those do under the hood. I've followed you on every single thing you've covered so far, and I think as interesting as it has been, it'll mean a lot more as I get deeper into actually using LINQ and get familiar with using each one of these operators. Okay.
Yeah, but I could honestly keep on going for days though. How about concat? Because concat's something that is really useful.
Sure.
I guess.
Yeah.
Concat does exactly what it sounds like it should do. These methods are really aptly named. I do want to point out that there's actually a long count. If you ever wondered what that's doing there. In LINQ, the long count is exactly like our count, except for it returns a long instead of an int.
Oh, okay. Yeah.
So
yeah,
it's kind of pointless to show.
Oh, you explained it right there.
Concat basically takes two enumerables. Well, one as a extension, and then another one as a
Clearly.
So concat is pretty straightforward. Remember that all of these methods actually have a validation on them. I'm ignoring that for now. Any idea what this might do?
Let me guess. You're gonna... Oh, I mean, not guess. Just from what I can tell. It's just going to... it's going to take in two arguments, and it's just going to return one after the other on each end. So if you got two enumerables, I misuse the word list all the time, but it looks like it would take in something like two lists, and then just take like the first two entries off each one, or the first entry off each one, then the second entry off each one, and then put them right next to each other, or one after the other.
Think about how the yield works. So each time, it's all good. Don't get frustrated.
I'm not.
Yeah, you are.
Not permanently.
Well, that's good.
Yeah.
That basically, until we move next. So we come through here. What are we returning from first? The enumeration that are okay. So each item of that's getting returned. Once we're done and move next, is called again. We've still got more to go.
Okay.
So then we're starting to return everything in other stuff.
So I mean, does it complete all of that before it goes to other stuff?
Yeah.
Okay.
Yep.
So we've just concatenated it into one big enumerable.
Okay.
These two things.
Basically made one list out of two. Which is funny, because that's what I thought it did based on the name, and then when trying to read the code, I got it all screwed up.
No, that's all good.
We should get 5 hays and 5, or 5 highs and 5 hays. Um, okay, because I made such a huge thing about our count,
Yeah.
I do at least want to talk about any real fast. And any is a really cool one that if you are using LINQ, you should know, because it can save you problems. Actually, there are two overloads to any. This is the first one. And then the second one takes a predicate. So Zach, just talking about the first are any. In the context of our count and how I said it's inefficient because it loops through every single element, can you see any situations where we could use any instead of count? At least the first overload, not the second one.
No, I'm afraid not.
Alrighty, so we can go ahead and let's create an Okay, so I basically created a method that simulates an IEnumerable that every time we call move next, it takes a second to calculate its next result. So that's what I'm simulating here. Imagine that you were doing some, crazy math or a database call or something like that. So if we were to just loop over this, we're going to be waiting a lot. We're going to be waiting for a total of 4 seconds. So 1, 2, 3, 4. So if we wanted to find out how many elements are in stuff.
Yeah.
So ignore the fact that this is a method. Just pretend this is a list. I guess you could say.
Sure, sure.
If we wanted to find out how many elements are in stuff, we could do this. We could do stuff.rCount. Unfortunately, this is going to take 4 seconds to execute. And we get 4 elements because we have 4 elements that are returning.
Right.
However, and many times we just need this. We just need to know, is there anything in stuff? We don't care about how many there are. We just want to know if there are any. And this happens a lot when you're working with collections or IEnumerables. We could return this with rAny, or replace this with rAny, and you'll notice we wait 1 second and then get a yes. So we wait only 1 second.
So it ran that first execution, and once it found that anything was there, that something was there, it reported back true.
Yes.
Okay.
So that's a very important. Always use any instead of.
Not necessarily. Oh, go ahead. No.
Instead of count if you're returning, if you're just wanting to see if there are any elements.
Okay.
What were you saying, Jason?
No. Scroll back up for me. Okay, good.
Oh, well.
No, nothing.
Okay. I got me worried.
No. All good.
Did I say anything wrong?
No, you're good.
Relax.
Okay. So if we pass the predicate version of any,
I mean, based on the functionality of the first one, this should be reporting back true if it finds anything that meets that criteria.
Right. So in this case, it's going to execute once, or it's going to go 1 second because it only takes 1 second, or it's going to do it 4 times and then say false, which is totally wrong. Probably have it backwards. rAny if predicate item. That's right. Jason, help.
Well, actually, something interesting is happening on our end. What did you just say, Zach?
His volume got really loud. I was
Yeah.
wondering if it's because he was breathing into the mic.
Oh, sorry.
It's okay. Nothing.
Or your dryer kicked up in the back heavily.
That's Mr. Furnace.
Oh,
Ah,
Mr. Furnace,
gotcha.
Yes.
There it
That's
goes.
good.
Now it's starting
Your hands
to
are
die
cold
back
enough.
Okay, but I'm kind of at a loss right now to
Happens to the
understand
best
why
of
this
us.
code is completely failing.
It's
Not only is it
still-
enumerating the
Yeah, it's
Yeah,
just running through all
collection.
4, and then saying false.
Okay, well, check this out.
Okay.
We have a debugger. Unfortunately, I have problems with finding the right. Okay, so that should take a second. Okay. And then if predicate item is 10, predicate is I is less than 1. Oh, that's why. Yeah, I don't know. No, I is less than 1, 10 is less than 1, 10 is not less than 1. 10
No,
is greater
10's
than
not less than 1.
1. I don't know what I was thinking there. Sometimes I have problems with math. So let's do I is greater than 1, and this will wait 1 second and return true.
Because it found something. So the problem before is it wasn't finding anything that was less than 1, and so it was having to cycle through
You
everything
had to
until
go
it
through the
eventually found
entire
something.
collection before it.
And then
Yep.
after
Said
those
false.
4 seconds, when it found nothing, and we waited through those 4 seconds, it finally just said, nope, couldn't find anything.
Right, and that's why if I is greater than 10, we'll do 2 seconds. Because it's going to be 10, and then it's going to be 11, and then it's going to be true.
Yeah.
Because it found that 11 is greater than 10.
Yeah.
There's another really close similar method called all, which is basically this in reverse. So all is just going to say, are all of these items greater, or are all these items greater than 10? And it's going to short circuit after one element because 10 is not greater than 10. But if we were to say greater than, let's say, 5, all those items are greater than 5.
Mm-hmm.
So we get true eventually. And if we're say 12, we should get false in 3 seconds. Or 2 seconds. Hold on. I is greater than 12. 10 is not greater than 12. Okay, so we get... if we do greater than equal to 10, then we'll wait 1 second and we'll get false. Or 5 seconds. I'm really bad at this today.
It's okay, man.
Because all of those elements are greater or equal to 10. But anyway, so that's any and all. Yeah.
Yeah, that's cool. We're actually at an hour 8 now since we talked about hitting, an hour at most. It's a good stopping point, Zach.
I think so.
I
I think it's a great way to break down LINQ. Now, if you want to end up doing this again sometime and find other aspects of LINQ you want to break down, I think that's still awesome.
I do want to. I have to. I'm sorry, Jason.
No, it's okay.
I know I was asking you for time, but then I was
Vetoed.
What?
Yeah. Okay. I did 2 important things. I removed the R prefix from select and where, so now it's literally just select and where. Notice that system.link is not referenced because this is important.
Mm-hmm.
Check this out. Okay, so it does everything we expect it to, but here's the cool thing. It's using... Oh, hold on. Sorry. It's using R select and R where, and I can prove that.
It has to be. I mean, LINQ, select, and where shouldn't even be there.
Right, because they're not imported in the...
I mean, there's not much to prove. It's like they didn't even show up for the party. They've got an alibi. Huh.
Where? Select 16!
Sweet.
Yep. So that's an important thing to know about how these fluent doohickeys work. The fluent query syntax is because it actually looks for a method that resolves on the IEnumerable class to where and to select that matches a specific signature, a signature that we've matched right here.
Yeah.
So it finds our methods and calls them.
Awesome.
That is really
So
cool.
cool.
Yeah.
Okay, well, this is a perfect spot to call it for tonight. That'll give you some great stuff to review as well, Zach.
Absolutely.
And
Coin of praise.
yeah. All right, well, that'll go ahead and wrap this video up. Nelson, anything else you want to add in?
No, I'm good.
All right, Zach.
No, thank you very much, Nelson.
Well, thank you, Nelson. Thank you, Zach. And thank you to all of our member sponsors out there for tuning in, for supporting us, and for watching these videos. Till next time, you guys all take care. Bye.